Hello there, pre-calculus students. Time for lesson 9-7, products and quotients of complex numbers in polar form. We're getting to the highlight of this chapter, which will be 9-8, where we'll learn how to find powers and roots of complex numbers. Here we'll share with you a couple of formulas how to multiply and divide complex numbers. You already know how to do that when they're in rectangular form, but now we're going to show you how to do it when they are in polar form. And it's really a pretty easy formula, even though this looks like a bunch of gibberish here. We'll see that it's really pretty handy. So, pretty short lesson here, I think, today, although it takes a while to simplify things, it seems like. Alright, here's the rule for products. Keep in mind, these are complex numbers, but we have written them now in this, what we call trigonometric form, or sometimes we call it complex polar form, that type of thing. So we have our R value, and we have our theta, so it's in polar form, but we have cosine plus I sine. So really what this is saying is that if we have two complex numbers in this trigonometric form, notice what this says, the two R values, we can multiply them, and the theta values, which are the angles here, we add them. So multiply the R's and add the thetas. That's kind of the key mantra for this little formula. And we'll do it right away. Alright, we want to try to find the product of 7. Notice I've abbreviated this cis. 7 pi over 12 times 3 cis pi over 12. Now the cis stands for cosine plus I sine, but it was easier to write it as cis, as you'll find when you're doing this as well. Alright, let's see if we can get to work here a bit. Now, we learned that when we're multiplying these, we actually do multiply the R values, so we have 7 times 3, but then we want to add the angle parts. So I can do that. What is 7 pi plus pi over 12? So I end up with 21 cis. I'll get 8 pi over 12. 8 pi over 12 will divide into 2 pi over 3, which, if you remember, is about 120 degrees or thereabouts. Now, the tricky part about this, that's your answer then, by the way. We could write that as 21 cosine 2 pi over 3 plus I times the sine of 2 pi over 3. Now, notice the problem does say, though, we'd like our final answer to be in rectangular form. So in that case, then, we have to maybe write this out a little bit more lengthily here. I'm going to write it in degrees just since I'm more familiar with that. 2 pi over 3 is 120 degrees plus I times the sine of 120. Keep in mind, that's my answer. Now I'm just going to try to write this in the rectangular form, the a plus bi form. Now the cosine of 120, if we think about that on our circle chart, that is negative 1/2, I believe. The sine of 120 is the square root of 3 over 2, like that. And because we're multiplying this by 21, then we do have to distribute. So I'd get negative 21 over 2 plus negative 21 times the square root of 3 over 2i. Not a real pleasant number, to be sure, but that's in rectangular form. As we have here, my final answer in rectangular form. Here's my final answer in trigonometric or polar form. Here's the super abbreviated version of that. Alright, really seems to be pretty commonsensical, I think. Here we talk about now dividing these complex numbers. Keep in mind, when we're dividing them, we could have done it exactly like we did last lesson or a couple lessons ago, where we have two complex numbers, we write them as a fraction, and then we have to rationalize that denominator. We have to get all i's out of there by use of conjugates, that type of thing. So we've done that before, but by doing this in polar form, this eliminates the requirement for us to do that. So it's a bit simpler process if we can get these numbers in polar form before we divide or multiply them. So again, as you notice, we're saying that now when we divide these complex numbers, notice the r values, we're dividing them. A couple of slides ago, remember, we were multiplying them. And as you might guess, now we are subtracting the angles rather than adding them. So just to summarize here, we're going to divide the r's, and we are going to subtract the thetas. So there's a nice connection between that and multiplication that you can hopefully read. All right, now we're just going to do an example here. And here again, I have written this in this trig form, but the abbreviated version, so 10 cis 3 pi over 10 divided by 2 cis pi over 20. So I know that first of all I need to divide the two r values, so 10 divided by 2, and then I know that I have to subtract the angles. Now this is a bit tricky. I like to get common denominators here, so do you see that this will end up to be 6 pi over 20 because I just multiplied by 2 over 2 here. And the reason I did that is because I know I have to subtract pi over 20. I have to have common denominators here. So I end up with 5 cis, and when I subtract these I get 5 pi over 20. And 5 pi over 20, of course, is the same as pi over 4. So I'm going to write this out a little bit more nicely here. 5 pi over 20 is the same as pi over 4. And we would recognize pi over 4 as an angle from our circle chart. So now in rectangular form I just have to substitute those values in. The cosine of pi over 4, the same as cosine of 45. That's going to be the square root of 2 over 2. Sine of pi over 4 is going to be the exact same thing, square root of 2 over 2. And when I distribute my 5, of course, I'm going to get 5 square root of 2 over 2 plus, let's see, 5, I should probably write that first, 5 times the square root of 2i over 2, like that. So that's in rectangular form. Alright gang, that's really about it. Two main formulas, fairly simple steps in learning how to apply them. We'll be practicing on this in class tomorrow. Thanks for watching, and we'll see you then.